Hi, everybody. Eric Knight with Orenda and Hasa here. This is episode 165 of the Rule Your Pool podcast. I'm doing this one alone, and I'm doing this sort of off the cuff because I talk about it a lot, and I didn't think I needed show notes. Not that Jared would read them anyway. I wanted to follow up on last episode where we talked about corrosion in episode 164. And the reason for this follow-up is because I've received a lot of text messages and phone calls from many of you. Pool pros and homeowners alike are really resonating with the last episode. First of all, I'm sorry to hear that because I hope you don't have corrosion in your pool, but many of you do. And it's a huge issue. And I didn't quite realize just how widespread it was until that episode went live last week. I want to follow up on it specifically because almost every question I got was about pool heaters. And oddly enough, the conversations with the people that I talked to often went back and forth between scale and corrosion. And of course, these are opposite ends of the spectrum in terms of the LSI. But the question is it possible to have both corrosion and scale in the same heat exchanger? We're going to talk about that in this episode today, 165 of the Rule Your Pool podcast. Let's get right into it.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
If you remember, if you've been listening to all of these, most of last trade show season, a certain class addressed 9 myths, disinformation being propagated in the industry. 8 of the 9 were supposedly coming from us, even though not one of them was a fair representation of what we teach. But that's besides the point. It was definitely targeted at Orenda, and I thoroughly enjoy every bit of it. It's some of the best marketing we've ever had, actually. One of those 9 myths was saying that LSI is the only reason for corrosion. Of course, we never say that, but we do say it is a reason for corrosion. And that is true. It is one of several. There's galvanic corrosion. You can have stray current. You can have other reasons, right? So the question is, can you have scale and corrosion in the same heat exchanger? The answer is actually yes. And I want to go back to the original reason that Dr. Langelier came up with the saturation index back in 1936. His entire purpose of doing this was to protect the pipes in the drinking water system from corrosion. He wanted to figure out the saturation point of calcium carbonate because calcium carbonate is corrosion resistant and it can coat the inside of the pipes. So he wanted to know, can we measure this? Can we do a very specific thin layer of calcium carbonate on the inside of the pipes to make them corrosion resistant? The answer is, of course, yes. Yes, you can. Now, if we take that into a pool heat exchanger, if we have scale in a heat exchanger, that would tell us that we don't likely have corrosion because it's corrosion resistant. But that's not necessarily the case, because what if the corrosion happened before the scale was there? Or what if it happens in between? What if it goes back and forth? And that's what we see in swimming pools. So let's just do a scenario or two. I'm going off the cuff here. I don't have any notes in front of me, but let's say the pool is started up the traditional way, not the Orenda way. Hey, put 7 or 8 gallons of acid in this, hot start it, because it looks like crap when it's done being troweled because it wasn't exposed very well, or it was overexposed and it wasn't bicarb rinsed to neutralize the acid. You know the drill. So we're just going to put acid in there for several days and cook it. So it looks even, Of course, those marks come back after 6 months or so, but that's a different issue. So there's a lot of acid. Now, you shouldn't be circulating at that time, but let's be honest. Most pools do. They turn on the circulation system as soon as that pool is full, even though they're not supposed to, and they circulate it. Well, that starts the corrosion process pretty early in a heat exchanger. Now, because we know during regular operation that the pH is going to rise, assuming you have the industry standard 80 to 120 alkalinity, like so many people do, the pH is going to rise into a scale-forming condition week after week. So scale deposits in the highest LSI places first, which tends to be the hottest places, which is going to be the heat exchanger or the salt cell or something like that. So you can get a thin layer of scale, even though the corrosion already started from the startup. Maybe you're trying to balance the LSI, but if you're not paying attention to the pH ceiling, pH rises up and it goes purple anyway. Purple, of course, being a reference to the Orenda calculator, and a purple LSI value is over 0.3 positive, and it's going to lead to some scale. Well, being the good homeowner that you are, you're trying to obey the piece of paper that you get from the retail store, and that software prints out and says, whoa, your pH is off the charts. You need to add acid. You need to bring it back down to 7.4. So you do. But that piece of paper doesn't say to dilute the acid. So, you just put the dose of acid and maybe round up a little bit. We want to make sure this doesn't happen again. Well, that goes down into the main drain because it wasn't diluted, and it goes down to the bottom because gravity is one of the 3 constants that we can work with. And it goes down into the main drain, and it starts to dissolve away some of that scale inside that heat exchanger. And if you do it enough, it might corrode a little bit. Then you stop. pH rises again. You might get back to a scale forming condition depending on the alkalinity. This is a real scenario that can happen. And we see it quite often where heat exchangers will be both scaled and corroded underneath. It's pretty wild. And this is why that happens. It's the bounce. It's chasing pH. It's chasing range chemistry. Something you can never actually catch because it's physically impossible. It is forcing water into an unnatural state. Good luck with that. Water is always going to return to its natural state, and the balance of gases in the liquid must equalize with the same gases above the liquid. That's Henry's law. That's where the pH ceiling comes from. We've got carbonate alkalinity, and if you've got 80 to 120, you're probably overcarbonated in that pool, especially if it's a saltwater pool. So the pH goes up. You get a little bit more scale. You got to knock that pH back down the next week. Boom, more acid. It could be worse. I mean, you could be putting trichlor in the skimmer basket. That's acid. Goes right through there. I've actually seen some equipment sets. This is a little bit of an aside. I've seen photos and some in real life where there's a trichlor feeder right before a heater. Pool pros listening to this are probably smacking their heads like, everybody knows not to do that. Well, clearly not. Somebody didn't know, because I've seen it. I've actually seen several of them in photos from customers too. They take on a pool. They're like, who did this? Who would put a trichlor feeder right before a heater? It's acid. But, nobody knows what they don't know. So I'm not going to criticize too hard. This is the Rule Your Pool podcast. This is about best known practices. Don't do that. And don't put trichlor in a skimmer. If you're running acid through a heat exchanger, it's likely going to corrode that copper nickel or copper heat exchanger. Now, there are pool heaters out there now that have titanium heat exchangers, and they're a lot more resistant, but they're not immune. They're just a lot more resistant. And while we're at it, copper nickel is a lot more resistant to corrosion than copper because it has nickel in it, but it's not immune. We all know, if you've been in this trade long enough, pool pros listening, copper nickel heaters can absolutely corrode. What happens when that corrosion gets to a point where the spa starts turning blue or turquoise or green? It's clearly oxidized copper getting into that pool and starting to stain. We see turquoise spas all the time. Terry Arco mentioned it in an episode. I don't know when we recorded it, maybe last year. And he was saying that there were people at this commercial property that just assumed that the spa was supposed to be that color, turquoise. No, it was white plaster, but it was so copper stained that it appeared that way. And that's because they were overdosing acid, not measuring it, not diluting it, not doing things properly. Acid was mainlining right into that system, or they were putting trichlor tabs in the skimmer. And I think in Terry's story, it was trichlor in the skimmer. But in any event, you can have both because of this chasing. pH goes up, you get to a scale forming condition, you beat it back down with acid or trichlor, and the cycle repeats itself. Pool pros listening to this, if you are servicing a pool once a week, and the vast majority of you are, you need to be aware of where the pH is going. Because if you're just focused on today, it's going to move. That's what the power of the pH ceiling is on the Orenda calculator. We didn't make it up. We just did the math for you. It was always going to happen. You need to know where it's going. I used this reference in a few episodes before. I'll say it again. A good quarterback in football does not throw the ball to where the wide receiver is. They throw it to where the wide receiver is going. You should do the same when you're treating pools. You need to know where the pH is going. And you need to make sure when you're there that you're LSI balanced. And when you show up the next week, don't overcorrect with too much acid. When in doubt, use less, dilute more. Because when you make that correction, if you overdose or you don't dilute enough, it can get down to the main drain, it can get down to the floor, it can etch, it can do all sorts of stuff. If you do that, you have problems that are heading your way. Let's say that the acid is neutralized completely on the plaster surface before it gets to the main drain. Entirely possible, acid will neutralize on cement. Right there, the LSI is so low that water's starving, so it etches and it neutralizes itself on the cement. But what's going to go into the main drain? Oh yeah, 12.6 pH calcium hydroxide was just dissolved. So a high pH, high calcium solution is going to get pulled into the main drain. And where's it going to end up? Your heater, because the heater's hot. It's a higher LSI, so it precipitates in there. You can actually accelerate a scale-forming condition by column pouring acid or just pouring acid without diluting it, because it's going to force that high pH, high calcium stuff that just came out of the cement into the main drain. And then it goes to the heater, falls right out. Isn't that crazy? Acid can cause scale in a heat exchanger? Yes, it can. It absolutely can. It's not like this happens overnight, but it does happen over several weeks. Certainly over several months if it's a repeated thing. So we recommend getting into the habit of maintaining LSI balance year-round by using the pH ceiling to your advantage. And dilute, and dilute it some more. Dilute that acid. Don't put it straight in the pool. Measure it. Use the calculator. We built it for you. It's free. Dose correctly. I don't care how long you've been doing this. If you just know by heart that it's got to be a half gallon of acid to do something, red alert. Most backyard pools never need a half gallon of acid, ever, unless it's a massive pool with very high alkalinity. Most acid doses, at least on the Orenda program for a 20,000 gallon pool, are less than 15 ounces. A half gallon is 64. So if you think it's a half gallon, and most people in my classes do, a quart, half gallon, sometimes a gallon, and that dose is actually, let's say 16 for easy math, a pint. If that dose is actually 16 ounces, you're doing 4 times the amount of acid that pool actually needs. So you're not going to 7.4. You're dropping it down below 6. That's going to be a red LSI. It's going to pull stuff out of that cement. And I don't mean to exclude the vinyl liners and the fiberglass people here, because it's going to damage those surfaces in a different way. I'm saying it because the vast majority of the problems that we hear about are on cement-based pool finishes. This is why. It reacts to a point where it will neutralize acid. Goes right into the main drain. Voila. Scale and corrosion in your heat exchanger. Now let me back up for a second. Let's talk about another way this can happen. I made mention in the last episode about black flakes in a saltwater pool. No, they were not calcium flakes. They were actually copper oxide. They were technically very dark green, but they looked so dark they looked like black flakes. Come to find out, it was not properly bonded, and there was a stray current between the salt cell, which was downstream, but the electrical current was going backwards against the flow of water to the heat exchanger, because that was the nearest anode that it could pull electrons from, and it did. And then it would corrode that heat exchanger to a point where it started flaking off. Remember deleterious corrosion, where material is deleted because the molecule size of copper oxide is larger than the copper itself, so it flakes off, especially in a high flow situation where water's moving all the time. And so it was blowing this corroded copper right back through the salt cell, which then oxidized it, so much so that it turned very dark green and blew into the pool as flakes. Those flakes were literally pieces of the copper heat exchanger that got oxidized further as it went through the salt cell and blew into the pool. That's crazy. When they took the salt cell apart, you could see a lot of the copper material wedged inside the blades of that salt cell. Isn't that wild? So electrical current doesn't care about water flow because it's just electron transfer, but it happened. So what could be done about that? Well, there's sacrificial anodes. We talked about galvanic corrosion, where you take zinc, which is as Alex says, is a juicier target, a much easier metal to corrode. It's a better anode. If you have a stray current, it's going to go after that sacrificial anode, and take electrons from that instead of going for the heat exchanger. I don't know where that should be installed. You should talk to your equipment manufacturer about that. They know way more about electrical stuff than I do. But every one of them will tell you that all that equipment needs to be properly bonded. And that doesn't mean you should go to any electrician who never works with pools. What you want is a manufacturer certified pool technician who has gone through the electrical education to know how to properly bond that system. And if you do that, it should stop the issue. But getting back to my point, you can have that kind of corrosion even if you have a positive LSI. It is entirely possible. The scale doesn't cover everything. The scale may coat the inside of the heat exchanger, but is it going to coat every millimeter of it? Is it going to coat every connection, every little metal fitting? Probably not. Anyway, I appreciate you listening to this. If you have had any of these issues, hopefully it helps explain why, and hopefully it helps you resolve them as well. Whether it's a sacrificial anode or just simple LSI balance and paying attention to the pH ceiling, you can prevent these issues from happening further, and I hope you do. We are in the business of best known practices, and we don't want you to set traps for yourself by unintentionally causing damage to pool equipment. Mistakes happen, but we can set ourselves up with the best odds of being successful by taking these variables out of the equation. And before we go, I do want to remind you that I'm going to be teaching the WaterShape University Service 1211 Basic Water Chemistry class. It's also called Essential Water Chemistry. And I'm going to be teaching that on January 27th at the Northeast Pool and Spa Show in Atlantic City. Space is limited, so you do need to get on the poolandspashow.com, search my name, just type in Knight or Orenda or something like that. You'll find it. It's the water chemistry class. It's an $800 class. It's a big investment, but it's an 8-hour accredited course. And pool pros listening to this, if you're sort of on the fence about spending that kind of money on a class, consider that it is never an expense when you invest in your own unique ability. That comes from a group called Strategic Coach. You can look them up online. Great organization. It's never an expense when you're investing in your unique ability to get better at what you do. There's a lot of great information in there. People ask, where can we get all of this stuff? Where do we get all of it? How do we get this story tied together about what water really is doing? Well, this is your answer. It's all here. It's in one book, and you will take this book home with you. It's got charts and formulas and everything. It tells the whole story, at least to the best of my ability. In the last 8 years of developing all this content for Orenda, this is like the culmination of all of that. Space is limited in this class, so the sooner you can sign up, the better chance you have of getting into it. It will be taught at the Atlantic City Show on January 27th, and I hope to see you there. And then on the Western Show, I will be teaching it February 6th, basically a week and a half later in Long Beach. Now, normally the Western Show is in late March, but California pros listening to this, pay attention because they moved the date. It is in early February now. So the show is from February 6th, 7th, and 8th. I will be teaching all day the 6th, and then the expo hall opens that evening, February 6th as well. Those of you who have been listening to this for a while, you already know that what we teach works and it makes sense. But it's so different from everything else you can get out there. And to be honest with you, I don't know why. I don't know why other people aren't teaching this material. Maybe it's verboten, but not to me. I want you to know what water was really doing, and you're going to get that in this class. Again, that is WaterShape University, Service 1211, Essential Water Chemistry. If you want more details on the class, you can go to watershape.org. I'm happy and honored to be one of their instructors for this class. And homeowners, I'm sorry, this is only for pros, but I'm thinking about maybe doing a homeowner handbook as well, but not yet. Thank you so much. This has been episode 165 of our little podcast here. And I do sincerely appreciate every one of you for listening to this and subscribing and sharing it. You've blown up our audience. It has just been amazing. It's kind of hard to believe when we look at the analytics on this that we are on pace to beat 300 listeners. No, Jared's not on here, but according to Jared, we almost have 300 listeners. So we got to get him over that line. Anyway, I love you all. Thank you.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.